The internet as we know it, it almost broke. Seriously. In its early days, it was built on a system with a really fatal flaw. Basically, a ticking time bomb that was about to go off. This is the story of that hidden crisis and the, well, pretty clever fix that saved our entire digital world.
So take a look at this number, 4.3 billion. Now, back in the day, that seemed like an enormous, almost infinite number. This was the total number of unique addresses available for every single device on the internet. Think of it like a street address for your computer or phone. This system was called IPv4. But as you can imagine, when the internet just exploded in popularity, it became painfully clear that 4.3 billion wasn't nearly enough.
And that really gets to the heart of the problem, right? What do you do when the demand just completely outstrips the supply? I mean, it's a recipe for a digital apocalypse where the internet's growth would just grind to a halt. So, to understand how we solved it, we first have to see why the original system was so incredibly broken.
So where did this whole mess come from? Well, it all stemmed from this really rigid, kind of one-size-fits-all approach. Or actually, as we're going to see, it was more like a three-sizes-fit-none approach that was just unbelievably wasteful.
This old system was called classful addressing. And the idea was, when a company or a university needed internet addresses, they were just handed a pre-packaged block in one of three fixed sizes. You had Class A for huge networks, Class B for medium, and Class C for small. And that was it. There was literally nothing in between.
Now look at the insane jump between these sizes. Don't worry about the first octet range, just look at the total addresses. You could get a tiny block of 256 addresses, or the very next size up was over 65,000. So what if your company needed, say, 500 addresses? Well, too bad. You were forced to take the 65,000 block, and all those thousands of extra addresses just went to waste. Nobody else could use them.
This chart just illustrates the problem so perfectly. Look at that disparity. You've got this tiny little Class C, a much bigger Class B, and then this absolutely monstrous gargantuan Class A with over 16 million addresses. It was like trying to outfit your kitchen and your only choices for pots were a thimble, a bucket, and an Olympic-sized swimming pool. It just made no sense.
And this analogy from our source material absolutely nails it. Imagine going to the store for bread, and your only choices are a tiny 2-slice pack or a massive 1,000-slice loaf. If you need bread for a family of 4, you have to buy the giant one. Most of it's going to go stale, but what other choice do you have? That is exactly what was happening with internet addresses.
And here's a real-world example of that waste in action. Say a company needed 10,000 addresses. They'd be assigned a Class B network, which gave them over 65,000. That means over 55,000 addresses in their block would just sit there, totally unused, reserved for them, but doing nothing, all while the rest of the world was rapidly running out of addresses. Yeah, this couldn't last.
Okay, so clearly the system was broken. A change was desperately needed. And thankfully, that change came in the form of a much more flexible, much more intelligent system that basically became the hero of our story.
And this slide just lays it out perfectly. On the left, you've got the old, rigid system with its three sizes, and on the right, the new solution. Instead of being locked into those three choices, organizations could now get an address block of practically any size they actually needed.
This solution is called Classless Inter-domain Routing, or CIDR for short. And its genius was actually pretty simple. It just got rid of the rigid classes. Now, address blocks could be assigned in a flexible size that actually matched what a company needed, which, as you can imagine, absolutely slashed the amount of waste. So let's go back to our example. Remember that company that needed 1,000 addresses? Instead of getting that massive Class B block of over 65,000, CIDR let them get a block of 1,024. Suddenly, the waste plummeted from tens of thousands of unused addresses to just 24. This was a total game changer that extended the life of the internet for many, many years.
All right, so CIDR solved the big, global problem of assigning address blocks efficiently. But once the company got their custom-sized block, network engineers still needed a way to organize all those addresses inside their own network. And this is where another crucial tool comes in, basically slicing up the network.
It's a process called subnetting. And think of it like this. If CIDR gives you a big plot of land, subnetting is how you draw the lines for individual lots for different houses or buildings. It's all about creating smaller, more organized, more manageable zones within your main network.
So how's it work, from a bird's eye view? Well, a network engineer starts with their main address block. They then use this special tool called a subnet mask to kind of slice off a portion of the address.
And this effectively turns one big network into lots of smaller, independent ones. One for the sales department, one for engineering, one for guest Wi-Fi, and so on.
And doing this has some huge benefits. It makes everything more efficient by keeping traffic local. It seriously boosts security by isolating these networks from each other. So if, say, the guest network gets compromised, it can't spread to the engineering department. And all of this reduces congestion and just makes the network faster for everybody.
Now, CIDR and subnetting were absolutely brilliant patches that saved the original internet, but they were still just buying us time. A true long-term solution was needed. And that solution is here now, and it's creating this new, unbelievably vast digital frontier that we're only just beginning to map.
Welcome to the future. It's called IPv6. And to put the numbers in perspective, if the old IPv4 system was a fishbowl, IPv6 is the entire known universe. It provides 340 undecillion addresses. That's a 340 followed by 36 zeros. It's a number so huge that we could assign a unique IP address to every single atom on the surface of the Earth and still have plenty of addresses left over. The problem of running out? Yeah, it's officially solved forever.
But this new, unimaginably vast internet creates a brand new challenge. How in the world do we map it? Specifically, researchers really want to find what's called the network periphery. That's the very last router your data talks to right before it reaches your phone or your laptop. It's the very, very edge of the internet.
And to do this, researchers created a special project they called EDGY. You can think of them as a team of modern-day digital cartographers, sending out these little probes to chart the millions upon millions of previously unknown routers that make up this new edge.
And this chart just brilliantly illustrates their success. I mean, look at this. Before EDGY, the best methods had found maybe 164,000 of these last hop routers. Using its clever techniques, EDGY discovered nearly 65 million of them. That is an absolutely incredible leap in our understanding of what the modern internet actually looks like.
But here's where it gets really fascinating. One of EDGY's biggest findings involved a specific address format called EUI64. And what's so significant about this is that this format directly embeds a device's unique physical hardware ID. It's called a MAC address. It's basically a serial number for your phone or computer, and it puts it right into its public internet address.
And that, right there, brings us to our final and pretty provocative question. We solved the address crisis. We built an internet with nearly infinite space. But in mapping this new frontier with such incredible precision, down to the unique hardware ID of a specific device, are we creating a brand new crisis? A crisis of privacy? It's a huge question we're all going to have to answer as we continue to explore this new digital world.